Hello everyone, my name is Eugene Ogambi Kebui. Based on videos provided by Technology Education Department, Moi University, I'm going to cover two areas in this video, that is the computer section, where we'll cover two subtopics, that is the SCADA system and the IoT, which is the IoT, which is the Internet of Things. And then there is the specialization area, which is the electrical and electronics. I'll cover the generation of electrical power. So we'll start with the SCADA system. First, SCADA system is the acronym for Supervisory Control and Data Acquisition. This is used for controlling, monitoring, and analyzing industrial processes. SCADA system is designed in various ways. First, I'll start with the hardware design, where the hardware design of the SCADA includes the field devices such as the sensors, actuators, programmable logic controllers, remote terminal units, and communication structures. Then there is the software structure, where the software structure design of SCADA system involves the development of custom software applications that run on servers in the central control center and the remote field location. Then I want us to move to the functions of the SCADA system, how SCADA system achieves its objectives. We'll start with the data acquisition, where the sensors collect data and deliver it to the field controller, which in turn feed the data to SCADA computers. There's also the data communication, in which uses the wire network to communicate between the users and the devices. And then there's the data presentation, where the hardware gathers and feeds data into field controller systems, which forward the data to other systems that process and present it into a human machine interface, that is the HMI, in a timely manner. There's also the control, where it uses different switches to operate each device and display status in the control area. A good example of where SCADA systems are applied is an oil plant control system, also known as the process automation system, which is designed to monitor, control, and optimize various processes involved in oil production, refining, and distribution by use of the process sensors, controllers, actuators, human machine interface, and the communication instructor. SCADA systems are also used in the electrical field, where power plants use SCADA systems to monitor and control distributions sectors, and also in optimization of overall network efficiency and to provide greater system reliability and sustainability. SCADA systems are also used in water distribution, where SCADA monitoring functions allow real-time insights across filtration plants, pump stations, and entire distribution network. They're also used in public utilities, for example, the bus traffic system to control and monitor the traffic, and also in airports, where they are used to provide real-time information to passengers and staff. They also, in the airport, they also help to monitor and control air traffic as well as navigation systems. Then we'll move to the Internet of Things, which is the next subtopic, which is a network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. There are different components of the Internet of Things. That is, one, to start with, there is the sensors and the devices, which collect real-time data, for example, the temperature in industries. There is also the cloud computing, which helps in data storage. There is security, which is a strategy to safeguard that helps to protect internet-enabled devices from cyber attacks. There's also the network, which is an interconnection of interworking elements that helps to account for the large amount of data that needs to be sent in short windows within a level of accuracy. There's a gateway also, which acts as a central hub and performs the necessary translations to allow the inter-device communication. There's also the last one, which we'll cover, is the user interface, which is what allows the human to interact with the Internet of Things devices and systems. Then I'll move to the next area, which was the specification area, that is the electrical and electronics, where we'll cover the technologies used to generate electricity. First, we'll start with the hydropower plant, where electricity is produced from generators driven by turbines that convert potential energy of falling or fast flowing water into mechanical energy. There are basic components of hydropower plant, that is the basic components that make up the whole power plant. We'll start with one of them, which is the dam or the diversion structure, which is built across a river or a water source to create a reservoir or a diversion channel. The water stored in the reservoir is then allowed to flow through the penstock to the turbine, which are large machines with blades that are turned by the force of flowing water. Then the turbines converts the kinetic energy of the water to the mechanical energy. After that, after learning that the kinetic energy is converted to mechanical energy by the turning of the blades of the turbines, I'll want us to move to the next component, which is the generator, which is the essential because it is driven by the mechanical energy from the turbines, and then it converts the mechanical energy to electrical energy that is then fed to the power grid or used on site. There are transformers, obviously, that are used to step up or step down the electricity for efficient transmission over long distances. The next terminology, or rather the next terminology is the steam power plant, which consists of a boiler, steam turbine, and a generator and other auxiliaries. The boiler generates steam at high pressure and high temperature. The steam turbine then converts the heat energy of steam into mechanical energy, and then the generator converts the mechanical energy into electrical energy. The next one is the coal power plant, which is a thermal power station which burns coal to generate electricity. The coal is usually pulverized, then burned in a pulverized coal-fired boiler. The furnace heat converts boiler water into steam, which is then used to turn turbines, which provide mechanical energy, and then through the process that we've earlier discussed, the mechanical energy is turned into electrical energy. Then there is also the last terminology which we'll cover today, that is the geothermal power plant. The geothermal power plant is a type of power station that harnesses the heat of the Earth's crust to produce electricity. Geothermal power plants typically operate in areas with high geothermal activities, such as the hot spring, there's the volcanoes, and there is also the geysers. That is the end of our video today. Thank you and nice time.